Good afternoon, my name is Ben Lewis, and this is Magnet Molasses, Lab 6. So the purpose of this lab is to investigate Faraday's law by observing what happens to a bar magnet falling through a conductive aluminum foil tube. The magnet produces a magnetic field which induces an electric field and a current in the tube. The induced current produces its own magnetic field which affects the speed by which the magnetic bar falls. And as a preview of the results, the experimental time was 1.25 seconds, and the computational time was 1.374 seconds. So key concepts for this lab was the Biot-Savart law describes the magnetic field generated by a constant electric current. Faraday's law says that the changing magnetic field creates an electric field. And Newton's second and third law, FMA, and reaction is an equal and opposite reaction. So as a procedure, the system was the bar magnet, the surroundings was the aluminum tube and everything else. And procedure, just dropping the bar magnet down an aluminum tube and then recording the time it takes to fall through. So for our data, we had a magnet mass of 0.025 kilograms, mu of 1.5 amps per meter squared, and then tube length of 0.3 meters, tube width of 0.01 meter, tube inner radius of 0.015 meter, and an average time of 1.25 seconds. So for my code, just entering in all the preliminary data in the beginning section, then creating a function to map the magnetic field of the bar magnet, and then creating a function to do the magnetic flux, then drop, here's the rest of it. And so the results up on the screen, and the assumptions for this was the bar magnet acts as a magnetic dipole, negligible air resistance, and no unknown forces. Errors that were part of this was electronic and magnetic devices affecting the data, friction caused by the tube, so tumbling, and then human error, of course. So the what ifs for this lab, what if the resistivity of the conductor was reduced as it close possible to zero? How would the dynamics of the falling magnet change? The induced current in the aluminum tube would become greater as IVR would create a greater magnetic force on the bar magnet, resulting in a slower time for the magnet to fall. What if the holes or slots were cut into the tube? How would this affect the ring current in your models? The induced current would be less due to the holes, which would result in the magnet falling faster. Thank you for watching.